In this video, we will show you how to generate Gerber files for PCB manufacturing. A Gerber file is the standard manufacturing file format for printed circuit boards, PCBs. It contains 2D vector graphics that describe every physical layer of a PCB, so fabrication machines can produce the board exactly as designed. This video uses the completed PCB design developed in the Fusion Inverting Amplifier PCB tutorial. A link to that tutorial video is provided in the description below. For a better understanding of PCB manufacturing, let's first examine the anatomy of a double-sided PCB, one of the most common types of PCBs used in everything from prototypes and consumer gadgets to industrial electronic systems. The illustration below shows the basic structure of a double-sided PCB. At the core of the board is the substrate, typically made from FR4, a fiberglass reinforced epoxy material. The substrate provides mechanical strength while electrically insulating the conductive layers. In many ways, it serves as the backbone of the PCB. On the top surface is the top copper layer, where electronic components such as resistors, capacitors, integrated circuits, and connectors are mounted. The copper traces on this layer function as miniature electrical pathways, carrying signals and power between components. The bottom copper layer is located on the opposite side of the substrate. This layer is commonly used for additional signal routing, ground planes, and power distribution. By utilizing copper on both sides of the board, designers can create more complex and compact circuits. Electrical connections between the top and bottom copper layers are made using vias. A via is created by drilling a hole through the PCB and plating its inner wall with copper. These plated holes act as vertical pathways, allowing signals and power to travel between layers. In addition to the copper layers, protective coatings are applied to the board surface to prevent oxidation and accidental short circuits, while silkscreen markings provide component labels and other assembly information. In summary, a double-sided PCB consists of a top copper layer, a bottom copper layer, an insulating substrate, and vias that interconnect the layers, along with protective and identification layers. While the structure is relatively simple, it enables the creation of highly capable and sophisticated electronic circuits. To transfer a PCB design from Fusion 360 to the manufacturing process, the design is exported as a collection of Gerber and drill files. The Gerber profile file defines the PCB's overall shape, dimensions, and any internal cutouts, providing the information required for board routing and machining during fabrication. The drill file specifies the locations and diameters of all holes, including component mounting holes and vias, enabling the manufacturer to accurately drill the PCB before subsequent fabrication processes. The conductive features of the PCB, including traces, pads, through-hole component pins, and vias, are defined by the Gerber top copper and Gerber bottom copper files. The solder mask openings on the top and bottom surfaces are specified in the Gerber top solder mask and Gerber bottom solder mask files respectively. Finally, the markings printed on the PCB, such as component identifiers, logos, and other reference information, are defined by the Gerber top silkscreen and Gerber bottom silkscreen files for the respective sides of the board. In summary, Gerber files are the standard manufacturing files used to communicate a PCB design to a fabrication facility. Each file defines a specific physical layer or feature of the board. Profile file defines the external shape, dimensions, and cutout features of the PCB, guiding the board routing process during fabrication. Drill file specifies the locations and sizes of all drilled holes, including component mounting holes and vias. Top copper and bottom copper files define the conductive copper patterns on both sides of the PCB, including traces, pads, and plated vias. Top solder mask and bottom solder mask files specify the areas where the solder mask is applied or opened, protecting the copper while exposing pads for soldering. Top silkscreen and bottom silkscreen files contain printed markings such as component reference designators, logos, polarity indicators, and assembly information. Together, these Gerber files provide all the information required for PCB manufacturers to fabricate the board accurately according to the original design. Next, I will show how to generate those Gerber files from Fusion 360. Open the inverting amplifier PCB created in the previous tutorial. Click Manufacturing on the menu to show the tool ribbon. Click Manufacturing here again and select CAM Processor. This is to configure the output of manufacturing files. Here, you will see the template to generate CAM files for two-layer PCB. ODB CAM file is a comprehensive PCB manufacturing data format that combines all the information needed to fabricate and assemble a PCB into a single dataset. It was developed as an alternative to Gerber files to reduce errors and simplify the transfer of design data from PCB design software to manufacturing equipment. We don't use this option. Therefore, right-click it and select Delete All. We also remove the assembly file because they are for the PCB assembly using pick-and-place machine. Now let's examine the Gerber files that will be used for PCB fabrication. There are two files that we have not discussed previously, the solder paste files. These files define the locations and dimensions of the stencil openings used to apply solder paste to surface mount pads before component placement and reflow soldering. Since solder paste files are used for stencil fabrication rather than PCB fabrication, they are not required for manufacturing the bare PCB. Therefore, we can remove them by right-clicking each file and selecting Delete. The auto drill file already contains the drill information for the PCB holes. Next, enable export as zip to package all of the Gerber files into a single compressed file. This is the preferred format for most PCB manufacturers because it simplifies file transfer and management. Select Gerber and uncheck Include Job File in Gerber Export. We will now simplify the file names. For each file, select it and remove the folder path so that the zip archive contains only the Gerber files without nested directory structures. Select Top Copper. This file contains information from 3 PCB design layers: copper top, pads, and vias. You can add or remove layers from the PCB design file by clicking here to select or deselect layers in the pop-up window. Since the default configuration already uses the standard layer setup, no modifications are necessary. Click Cancel to close the window. Remove the file path and name the file copper_top.gbr. Select Bottom Copper. This file also combines information from 3 PCB design layers: copper bottom, pads, and vias. Remove the file path and name the file copper_bottom.gbr. Select Profile. This file contains the PCB outline and mounting hole geometry derived from the board shape and cutout layers. Remove the file path and name the file profile.gbr. Select Solder Mask Top. This file contains data from the top solder mask layer of the PCB design. Remove the file path and name the file soldermask_top.gbr. Select Solder Mask Bottom. This file contains data from the bottom solder mask layer of the PCB design. Remove the file path and name the file soldermask_bottom.gbr. Select Silkscreen Top. This file combines information from the silkscreen top and names top layers. If you would like to display component values on the top layer of the PCB, click the Edit button and select the Values top layer. We don't need the modification, so click Cancel to close the window. Remove the file path and name the file silkscreen_top.gbr. Select Silkscreen Bottom. This file combines information from the silkscreen bottom and names bottom layers. Remove the file path and name the file silkscreen_bottom.gbr. Lastly, select Auto Drill. Remove the file path. Name the file drill_1_16.xln. After completing these steps, the zip file will contain a clean set of Gerber files and the drill file required for PCB fabrication, making it easier for the manufacturer to process the design accurately. The next step is to export the Gerber files into a zip archive for manufacturing. Click Save to store the CAM job on your computer for future use. Name it My 2-Layer PCB. Click here to set the job as the active CAM job and close the window. Go back to Manufacturing and select Export Gerber and see Drill, Assembly, and Drawing Outputs. You can verify the files in the list. Click OK. Enter a file name, Inverting Amplifier, choose the download folder, and then click Save to export the files. Once the export is complete, locate the generated zip file in the download folder. This archive contains all the Gerber files and NC drill data required for PCB fabrication. This concludes the demonstration of generating and exporting PCB manufacturing files from Fusion 360. Here is an overview of generating Gerber files from Fusion 360 PCB design projects. The same workflow applies to most other EDA tools. A single physical PCB layer is often mapped from several design layers, giving the software flexibility and finer control. Once generated, the Gerber outputs are typically bundled into a zip archive. You can then upload this zip file to your chosen PCB manufacturer for fabrication. If you found this video helpful, please like, share, and subscribe for more content.